Now that we have a better feeling of what vectors are, let's talk a little bit more about this concept of the unit vector. And although we typically only use the unit vectors that point in the orthogonal Cartesian system, and by that I mean the x unit vector, the y unit vector, and the z unit vector, where each of these point purely in one direction and have a magnitude of 1, and their notation is a hat x, a hat y, and a hat z. There's really no restriction on the direction of a unit vector. I can define a unit vector for any direction, and I do that by taking the vector that points in the direction that we're interested in and dividing it by the magnitude of that vector. So for example, let's have a vector that points in 3 directions. We'll call it vector p, and it's going to have some magnitude pointing in the x direction. It's going to have some magnitude pointing in the y direction, and it's going to have some magnitude pointing in the z direction in the Cartesian system. The magnitude of that vector, which we indicate by just putting the absolute value sign around that, that's our usual notation for magnitude, is just the square root of px, the magnitude in the x direction, squared, plus py, the magnitude in the y direction, squared, plus pz, the length in the z direction, squared. We just take the square root of the sum of those 3 squared terms. And a unit vector that points in the same direction as p does is then defined as a hat p, which is p, the vector, divided by the magnitude of p. And if you were to write this all the way out, you would see that a hat p is just equal to px over the square root of px squared plus py squared plus pz squared, and that points in the a hat x direction, and you've got plus py over px squared plus py squared plus pz squared, a hat y, plus pz over the square root of px squared plus py squared plus pz squared, a hat z. So this is the unit vector a hat p, which points in the same direction as the vector p. One thing to be careful is if you use multiple references, is that pointing in the x direction, I use a hat x. Pointing in the y direction, I use a hat y. Pointing in the z direction, I use a hat z. That's not the only way to do that. Another very popular formulation, which is I hat, which corresponds to the x direction, j hat, which corresponds to the y direction, and k hat, which corresponds to the z direction. This notation, the IJK notation, is favored by physicists, so if your favorite reference uses that, you know how to convert between the two notations. So let's do an example of a unit vector, and I've got a vector that starts at point a, b, 0, and it ends at point 0, 0, h. So a, b, 0, we come out a units in the x-axis. We come out b units in the y-axis. We find the intersection of those points right there. And the point 0, 0, h, we go 0 in the x, 0 in the y, and then h units in the z direction. So we want to find the vector that points from this point here to this point here. And you can see I've drawn that in there. So to name that vector, we'll just call it p. Notice we've got the arrow on top of it. Remember, the formulation is to take the direction, the magnitude for each of the cardinal directions, and subtract them. So here we have to have 0 minus a, and that points in the x direction. And then we add to that 0 minus b, a hat y, and then we have h minus 0, and that's a hat z. And so we can just do some basic distribution. We get minus a pointing in the a direction, minus b pointing in the y direction, plus h pointing in the z direction. The magnitude of this vector is minus a squared plus minus b squared plus h squared, which is just equal to the square root of a squared plus b squared plus h. And so a hat p, the unit vector pointing in this direction, so same direction, magnitude of 1, is just going to be minus a over the square root of a squared plus b squared plus h, and that's in the x direction. And then we've got minus b over a squared plus b squared plus h pointing in the y direction. And then we've got plus h over, oh, I'm leaving off the squared off those h's, those all have squares on them. A squared plus b squared plus h squared a hat y. So now we have the unit vector pointing in the same direction as vector p.